Today we will discuss the remaining general electronic properties of the noble gases. In the last class we have discussed the electronic configuration, ionization energy, electron affinity, and the remaining general property we will discuss here. So the next property is the oxidation state and the reactivity of the noble gas. As you know that the noble gas are almost inert, but only the xenon react with the other element, and to form there are numerous xenon compounds are available in which xenon exists in +2, +4, +6 and +8 oxidation state. So these are the example: XeF2, XeF4, XeF6, XeOF4, XeO3 and Xe2OF2 and XeO4. See, the xenon is react with the most electronegative element, that is fluorine and oxygen. Okay. Now we are moving into the structures of the xenon compounds in detail. So first is the XeF2. So we know that the general electronic configuration of the xenon is 5s2, 5p6, and fluorine is 5s2 and 2p5. So in order to form the 2 sigma bond with the xenon, one of the electron in the p orbital of the xenon is excited into the d orbital, and the s orbital and 3p orbital and 1d orbital undergo hybridization, and to form the 5 sp3d orbitals, and the 3 of them contain lone pair of electron. Remaining 2 half-filled hybridized orbital combined with the atomic orbitals of the fluorine and to form XeF2. See, we know that the lone pair of the electron are exist in equatorial position in order to reduce the repulsive force between this pair of electrons. So the 3 of the electron pair, lone pair of electron, exist in the equatorial position, and 1 of the half-filled orbital is exist in a axial position. 2 of the half-filled orbital exist in the axial position. So the actual geometry is the trigonal bipyramidal, but if we avoid the lone pair of electrons, so the geometry is linear in character. Now we are moving into the next molecule, that is XeF4. Here also we have 4 half-filled orbital for the xenon in order to form the 4 sigma XeF bond. So two of the electron in the p orbital is excited into the d orbital and to form sp3d4, sp3d2 hybridized orbital, and the 4 of them are half-filled, and the remaining 2 electron exist in the axial position. Here the lone pair of electron exist in the axial position in order to reduce the repulsive force. Now we are moving into the next molecule, that is XeF6. The ground state electronic configuration of the xenon is 5s2, 5p6 and 5d0. And we have to form the 6f bond, XeF bond. So for that, the 3 of the electron in the p orbital is excited into the d orbital, and the hybridization is sp3d2, and to form the hybridized orbital combined with the orbital of the fluorine, and here we can see that a lone pair of electron. So the actual geometry of the molecule is pentagonal bipyramidal, but due to this lone pair of electron, it forms a slightly distorted octahedral shape. Thank you.